Before we start learning vectors at JC, okay, let's recap some of the things that we have learned in vectors at two-dimensional space in secondary school, in O levels, okay? So if A has a coordinates of x, y, and we put it in the vector form, it must always start with O, okay? This is also called as the position vector. In this chapter, you will see a lot of position vector. So when the question say position vector of A, this means OA. This also means your coordinate form can change to a column vector form in x, y form. And the magnitude of OA is a Pythagoras theorem of x squared plus y squared. Why? Because all coordinates over here, x, y, is with respect to the origin. This is A. So this is the x, this is the y. If I want the length of OA, it's a Pythagoras theorem of x squared plus y squared. And next, because vector has magnitude and direction, if you go into the opposite direction, there must be a negative sign. OA equals to xy. AO, it will be the negative of OA, and that will be the negative of xy, and you can say that it's negative x, negative y. Okay, so these are just the basics. The most important thing is when you see position vector, you must think of OA. Okay, when we add vectors, okay, when secondary school we do a lot of adding, and Mr. Ivan, if you follow my learn 30 minutes, learn vectors in 30 minutes, you will know that I say that we always do plus so that it's easy for you to remember. From A to C, okay, I must go from A to B first, and then B to C, and then this is my resulting vector, A plus B. Mistake number one, never think that the vector triangle can never go in one round. That means your arrow cannot turn one round to go back to the original. No, this is wrong. Okay, so one way I told you all in secondary school is the middle 2 points, okay, must tally. Then you can form the addition easily. Okay, now you may also have been taught that AB is equals to OB minus OA. It's actually easier to see it as plus, but just that in JC, right? Because now we are doing higher level, you are supposed to know it is the position vector of the behind guy minus the front guy. I always make things easy for you. Why? Because I know that AB is equals to AO plus OB, and because usually we do it in the position vector form, right? AO is negative of OA, just as above, because I changed the direction, plus OB. Okay, yeah, so it's very common to use OB minus OA in this case, or in JC, OB is usually represented just by B alone, B minus A. So once you see, oh, what is B minus A? Immediately you must identify that this is called AB. Okay, what is P minus Q? Immediately you must identify this is called QP, because Q and P are with respect to O. Once you see C minus A, what must you know? Immediately you must know this is AC. So that's why I say the behind guy will always be in front if you are minusing. The behind guy will always be in front when you're minusing. The behind guy will always be in front when you're minusing. So this is how we do addition and subtraction of vectors. Okay, it's important to know the minus part from now on because you have to identify it. So next, if I multiply a vector by a scalar is like a constant, it's just a number. A scalar is a number. So when I multiply it by a number, okay, I am extending it, okay, with a multiple. Of course, the multiple can be greater than 1, can be lesser than 1. So you see in this case, if A is this, what can I say about B? B is 3 times of A, right? Because they are in the same direction and the length is multiplied by 3. What if the direction is opposite? Then C is called negative 2 of A. Easy, okay? Because it's in the opposite direction and the length is 2 times. So if the question tells you that they are parallel, so this is the part that students in O level very hard to understand and you have to carry on to A levels, is when the question tells you they are parallel already, you can say that A is equals to K times of B. And you know, in JC, it's just that we don't use K anymore. We say that B is a lambda kind of A. Can be vice versa, etc. We use these two symbols. This is called lambda, or we use another one which is called mu times of A. Okay, so this is called mu. Instead of K and H, we use lambda and mu because these are Greek letters that mathematicians use. Next is if I want to show that two vectors are parallel. So in secondary school, most of the time we are given vectors as numbers. So we have this and we have this. So I can see obvious, always factorize out a constant from the bigger vector. So this is the bigger vector, right? I factorize out a 5, I can say that is equals to 5CD. So when you can factorize out a constant from a bigger vector and is in terms of a shorter vector, you must talk about two things. Number one, it is parallel. Number two, it is the ratio of the length is this. Okay? And one part I missed out is talking about collinear. Okay? Collinear. So remember, what is the meaning of collinear? They all lies on the same straight line, right or not? Okay, so this way is called AB produced. Q lies on AB produced. Okay, yeah, so AB, so remember just now I tell you AB must always identify this as B minus A. Okay, if you can show that AQ is equals to lambda kind of B minus A. Okay, what does it mean? So it means that AQ is parallel to AB, and because they have a common point, and since they have a common point A, we say that A, B, and Q are collinear. Okay, and in JC, most of the time the ratio is not a number. It's not a number. So AQ is lambda kind of B minus A. All you need to say is that this guy is 1. Okay, and AQ is lambda of this. So this guy is called lambda. And what is the ratio of BQ? BQ is called lambda minus 1. Just like that. Just all in terms. Lesser numbers, more alphabet, more general term. But the two things I want to talk about this is, number one, if you know that they are parallel, or if you know that they are all collinear, you can say that B is equals to lambda of A, or vice versa. Okay? And if you want to show that two vectors are parallel, then you have to show that you can factorize out a constant, okay, and show it's a multiple of a constant, and this is called like the scalar multiple. Okay? You have to get this concept right first before we go on.